Hi everyone, it's Jonathan. Hopefully everyone's having a good day and then is ready for a productive weekend. I'm making this video because at the end of last class, we did not quite have enough time to go into a few things, and we just sort of ran out of time there at the end. But in any event, there was one thing I just wanted to make sure I had time to go over, at least going into the weekend, because I think it'll help you guys out a lot, because the whole point about homework 3, right, is developing, kind of a framework, right, for applying a model to data and kind of going through the whole process. And pre-processing is a big part of it, and it's very, very prone to error. Okay, so the big thing about pipelines and transformers, which we got into a little bit before class ended, is it makes that whole part of the process a lot easier. Okay, so what I'm going to do here is make a little video that kind of walks through some of the things that we didn't have a chance to go over towards the end of class. So the idea then, if you want to, you can go ahead and watch this and then use it to sort of help you out with your own homework. And then also, if we have questions about it, we'll do the flipped classroom format. And so you can watch this, and then any questions you might have, you can ask me about it on Tuesday before we keep on. So, all right, so in any event, where we left off was the idea that there is a pre-processing module in scikit-learn, and this allows you to automate a lot of the different steps, okay, that you do for scaling and encoding and things like that. All right, so what we're going to do here, I'm in the messy notebook from last class right over here, just loading in a few different things. So I'm just going to go through this and just kind of rehearse a little bit of what was discussed towards the very, very end of class. All right, so let me just go through all of this. Actually, a lot of this I don't think I need. Actually, quite a bit of this I don't think I need. Let me just go ahead and just make sure. This one I do need, the pipeline. And then let me take a look at the preprocessor. Okay, like this. Okay. All right, now let me try it. Ridge is not defined. So actually, let me just go ahead and restart this and then just run the whole thing. All right, and then I'll let that go here. Basic idea, though, the big part about pipelines is there's something called the Transformer API in scikit-learn. And so what that means you have a number of things here. Okay, if you take a look at the methods they have available to them, okay, you'll see here you can fit, right? We're kind of used to that, but kind of the big thing here, right? They have these methods called fit transform and then transform right over here like that. So pretty much if you have a method in scikit-learn or elsewhere that have these methods attached to them, that basically makes them a transformer, all right? So kind of what we discussed before, right? This is the standard scaler, so it scales your data like we've discussed previously. All right, if you fit on one block of data, right, you can transform a new block of data based off the saved information that happens right over here like that. So when you call fit right over here in Xtrain, what's actually happening, take a look to see if I can find it. Okay, right, with the underscore here, we have var and mean. So the idea then, right, once you call fit, it saves the variance of every single column, and then saves the average of every single column that it gets fit on, and then it uses those values to transform new data, all right? So it just makes it a bit more of a streamlined way to go ahead and then apply various types of transformations, because you can store the key info that you need to go ahead and apply to other items. All right, so we talked about that, and the last thing we discussed was the idea of a pipeline. And so a pipeline is just a way to chain together multiple transformers with a predictor if you want. So what that means, right, there's a function called pipeline. And then the way this works, right, all that you have to do here is just pass in the different steps that you want to go ahead and then transform, and if you want to, predict your data. You don't have to have a predictor at the very, very end. That's actually up to you. Okay, but you can if you like, and so pretty much now, what we have here, the pipe like this, what it's going to do, it's going to apply the transformer right over here, and then at the very, very end, use the predictor afterwards. So if we run this, right, we can fit it on X and Y. Keep in mind, important detail to sort of bring your attention to here. Because the last item in the pipeline is the predictor right over here, we have to call fit just like we would be using linear regression. Okay, it's an important detail. So the methods available, okay, to the pipeline tend to coincide with the last item inside of it right over here. And then all of these just get applied beforehand, okay? So in this case, with linear regression, obviously you have to sort of fit on X and Y, so we have to follow the same conventions right over here. And then this just gets applied automatically before we go through the final step. So we run this, and then we still, where am I at over here? Take a look. Found, okay, that's right. Sorry, it's not X train, it is Y train, okay. All right, so we do that. And then the idea then, right, we can go ahead and then make predictions on the test set. And then what's important here, right, the predictions on the test set already have this pre-processing step, okay, applied to it, okay? So that's the basic idea. This is just a standard scalar with linear regression. All right, but there are a number of ways you can transform your data. All right, so if you go over here, I'm on the home page for the pre-processing module. Okay, right, you can see here there's any number of things you can do. Okay, a big thing here, right, there are also columns for encoding, right, encoding categorical features. You can use that right over here. However, though, one thing we're going to talk about, we didn't get a chance to do in class, so I'm going to talk about it now, is probably a better option for encoding categorical features that is not inside the standard scikit-learn library. If you're curious, you can kind of try it yourself to see why I'm about to do what I'm going to do, but the basic idea is, in my opinion, the categorical encoding portion of the transformer API in scikit-learn is not very user-friendly and difficult to work with. All right, so the alternative is an extension. Okay, there's a library called Category Encoders. Okay, so if you just search for this, you should be able to see it. Okay, it'll bring you to this page right over here. This is a much more useful way to encode categorical features and then encode them in pipelines. And so the idea here, you have to install it separately. So what you should do, if you're using Anaconda, it's probably best just to use the conda install command right over here like this. Okay, and so what we can see here, this is a library that have these different encoding techniques built into them. These range to the relatively simple and straightforward, like ordinal encoding, and some of these essentially apply their own algorithms to kind of go ahead and then kind of impute, the values for different categorical values. So there's actually a lot of really useful techniques built into this. But right, we discussed previously, ordinal encoding, and then where is it? One-hot encoding right over here. So we'll just stick with that. All right, so what I'm going to do here is walk through how one would go ahead and then use the category encoders library on the Iowa housing data set. Okay, so let's go ahead and just take a look to see what it does. Okay, so what I'm going to do here. Okay, so I am in the lab for the final step here, right, for step 3. So what I'm going to do here is I'm just going to walk through this lab and then use the category encoders library to finish off our pipeline. I think you'll see a lot of what we were doing before and then some of the problems with it are basically just going to dissolve away. And it just makes it a very, very, very easy way to kind of go ahead and then plug in data into your model and test out different results. Okay, so what we're going to do here, I'm just going to copy and paste these answers, right? So the first one is just to reload training and test sets and then create variables for Y and sale price and ID. This is basically just, stuff that we've already done before. So again, I like to recommend people, I understand if you haven't done this stuff for the first time, it's usually a good idea to type these out by hand. But in our case, just for time, I'm just going to go ahead and then copy and paste all these things. Okay, like this. Okay, la 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 la. I probably didn't import pandas. Yep, so I'll go ahead and do that now. La 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 la. All right, and I'll import NumPy. It's probably a good idea. All right, so we'll give that one a minute. Okay, and then after that, so fill in the missing data on training and test. I'm just gonna go ahead. Alright, and do that. And then, right, remember MS subclass is basically a categorical column. It's encoded as a number, but it's essentially a category. Okay, so now the idea then, right, is we have these steps filled out right now. So now what we're going to do is work on building our pipeline. Alright, so let's take a look. First thing I want us to do is let's see how the category encoders library works. Okay, so what I'm going to do over here. Okay, it really works a lot like scikit-learn. So the syntax is almost exactly the same. So here, I'll make a variable here for ordinal encoder. Okay. So the idea then, I think I have a variable here called train. Just let me just double check. Okay, yeah, here we go. All right, so the way this works. Okay, if you just pass a data set, okay, into whatever the fit transform method, or fit if you wanted to, okay, we can see here things like MS subclass, neighborhood, a few of the other ones, garage finish, right? These were categorical columns before, and so we can see it just automatically ordinally encodes all of them, okay? Now obviously lots of times you have a mix of columns that you want to apply different transformations to, right? Like not just one. Okay, so for example here, if we remember previously from the lab, the column that was deemed categorical was garage finish right over here, right? So it had values like finished, unfinished, partially finished, and none. So the idea is you can kind of like establish a hierarchy there. So the way you would go ahead and get around this, you'd create a dictionary. We'll call it mapping. Okay. The dictionary basically has two different values that you pass in. The first value is called call, and then the value for that is the name of the column you want to pass in. So we'll say garage finish. Okay, the second value is called mapping, and then the value for this one is a dictionary. Okay, and so that dictionary is basically just a list of the values that you want to encode. Okay, so in this case, I'll do this. We'll make none, 1, 2, 3, right? Because that is how we want to go ahead and encode things, right? So we'll say none, and no basement is worse than an unfinished basement, which is worse than a partially finished basement, which is worse than a fully finished basement, okay? Let me just go and double check just to make sure that's correct. I think that's what... I think that's what we have here. I'll just sort of trust that that's good, okay? All right, we'll do that right over here. Okay, so now we'll do this. Okay, and so now then, if we want to go ahead, okay, and do this, what we can do then, there's an argument called calls. Okay, so we'll pass in the garage finish column because that's what we want to do. And so the idea is we want to have our own mapping.